we have Navendu Pottekkat, who is a developer advocate at API 7.ai, and he is going to present hands-on on new Kubernetes Gateway API. So in this talk, he will explore how gateway APIs are evolved and solve the shortcomings of the API with some hands-on examples.
So maybe we can start with a show of hands. How many of you are familiar with the Gateway API? Oh, that's nice. And how many of you are not familiar with the Gateway API, but with the Ingress API, Kubernetes Ingress controllers? Okay, that's nice. So today I wanted to talk about the new Gateway API. New is a relative term because Gateway API has been around for some time now, but it is still new in terms of implementation and its uses. So hopefully by the end of this talk, you will learn about what the Kubernetes Gateway API is, how you can use it, and why you should or shouldn't use it. A little bit about me. I work on an open source project called Apache API 6. I used to work on some CNCF projects. I try to help open source contributors through Google Summer of Code and the Linux Foundation mentorship program. If you want to find me online, I'm mostly active on Twitter. All right. I think an important part for understanding the Gateway API is to see how it evolved. And the Gateway API didn't come just out of the blue. It was an evolution led to this Gateway API. So let's look at what this evolution is. In Kubernetes, everything is a pod. And technically, we can just send requests to this pod and access our application. But pods are temporary. They can spin up and they can be deleted instantaneously. And it doesn't make sense to keep pointing to a pod because there is no static IP address that you can readily access. And that's where services come in. So they offer a layer of network abstraction over pods. And you have your cluster IP, which exposes your pods in the internal to the cluster. Then we have node port and load balancers. These can do a lot of stuff, but they are quite limited. They don't do stuff like routing or complex traffic control features. So we moved to the Ingress API. And Ingress API is basically a standard API provided by Kubernetes that lets you define how you can define how ingress traffic or traffic into your cluster comes. And it is just an API, and you have to implement this API to actually have something to route this traffic. And there are 20 plus implementations of the Ingress API. And Apache API 6 Ingress is one such implementation. So basically, Apache API 6 is an API gateway, and it has an Ingress controller wrapper around it. So API 6 takes this Ingress controller takes the Kubernetes definition, the Ingress API file, and it translates it to an API 6 configuration, and API 6 handles all the traffic. So you define what you want with the Kubernetes Ingress API, and then API 6 does it for you. And API 6 is built for a cloud native and a high performance environment, and it is hosted by the Apache Software Foundation. You can learn more at api6.apache.org. So let's look at some code and see how this all works. So our sample application is quite simple. We have a Kubernetes cluster, and we have two Nginx servers running. These are just bare servers. We have two versions of it. One is called left, and the other is called right. So the left server basically just says left when you send a request to it, and the right server says right. And we have our Ingress Apache API 6. So API 6 will take the Kubernetes, the ingress you define in Kubernetes, and then hopefully it will route the request. And we'll send requests through a CLI. So if you send a request left, API 6 is supposed to route it to the left service. and we will configure this through the ingress. All right. I hope you can see this. Okay. So I have a Kubernetes cluster, and I have uh, and I have deployed API 6. I have deployed our sample applications. I have installed all the CIDs, which we will look into in some time. So let's first look at the ingress definition. All right. So the ingress API is available within Kubernetes out of the box. So we will create an ingress. And basically what we are defining is if a request comes to the left path or has the left prefix, we should route it to the service named left, which is our Nginx service. And if it is right, we should route it to the right service. Oh. So let's try doing that. Okay. So I applied this YAML file, and let's see. Let's try to send a request to the ingress, and it says left. Now if we just change this to right, we get a response back from the right service. Now let's try doing something a little bit more complicated. So we have a request to left /app, and we want our ingress controller to cut down the left part from the request and use and only forward the suffix of the request to the backend services. So basically, the ingress controller chops down this left part and sends it to it. It basically modifies the request, right? Let's see how we can do that with ingress. And to do that, you need annotations. So the ingress API is pretty limited in what it can do. And a way to extend it is using annotations. So annotations are basically just strings, right? And we have this long annotation for API 6, which basically uses some regex to eliminate the left or the right part. And this annotation is specific to API 6. So even if you are using the Kubernetes Ingress API, which is a standard, which is a specification, you end up using these proprietary annotations. So what it does is quite simple. We have a similar definition as we had before, but we have this extra annotations. So if I remove the earlier configuration and then apply our annotation, the ingress spec with the annotations, and let's see sending a request, right? So we send a request, write hello, and from the server we get back just the hello. It omitted the right part, and this is done with the annotations. But as you can see, like annotations can become overwhelming because it gets difficult to maintain. So 2 annotations are quite easy to maintain, but the Nginx Ingress has all these annotations. So it may be easy to set this up, but it is like a nightmare to maintain. So annotations basically suck, and the Ingress controller developers, they wanted to do something different, right? So they ended up creating their own CRDs. Instead of using the Ingress API, each of these ingress controller implementations, they started creating their own CRDs. So API 6 has their own CRD called API 6 route. And it lets you do a lot of stuff that API 6 is capable of within Kubernetes, right? Since the ingress controller was limited, we tried annotations, but annotations was too much of a nightmare, and then we started using CRDs. All right, so it lets you do a lot of stuff. So in this example, we have a CRD that basically checks the query in a request and use that to forward or use that to control traffic within the cluster. And let's see this in action. I will just delete the earlier one just to be safe. Okay. All right. Now if let's see. Okay. So now if I send a request to our ingress to the API endpoint and add a query that says side is equal to right, it should send the request to the right service, the right Nginx service, and it should also modify the URL and adds a string called string rereturn, as we mentioned in our CRD, right? So CRDs made it a lot easier to use ingress controllers, but it means that like you have to stick to this specific implementation. You cannot take the CRD and switch API 6 with another ingress controller and it won't work. So it defeats the purpose of having a standard specification to define how you want your traffic to go, right? And yeah, so we are at the ingress level in our evolution, but as we saw, like it had a lot of limitations. So it requires custom annotations to make it useful, or it needs CRDs. And if you end up using annotations or CRDs, it becomes not portable, and you are basically logged in with that vendor. And even if you have more features, there is no standard way to extend this other than annotations. And that's where we evolved to the Gateway API. So Gateway API is a sort of like a next step to this Ingress. It is different from the Ingress project, and it aims to be expressive. It lets you do a lot of stuff out of the box, and it aims to be a standard. It aims to provide a standard way to extend new features to the Gateway API, and it is also role-oriented, which means that multiple people can work with the API. So if you are an application developer and you are using a shared cluster, you just have to worry about creating the routes. A cluster operator can manage the gateway, they can set up policies, and they can also give you the freedom to work with your application and create routes on your own. So let's look at this in action. So we'll do the same stuff, but instead of the Ingress API, we are using the Gateway API. So So Ingress API has something called HTTP route, which we just saw. So as an application developer, I'm concerned about creating an HTTP route. There is also TCP route, but you can check that out later. So yeah, so we'll do the same thing as we did before. We'll try to match a query parameter called site, and if its value is left, we'll just forward it to the left service. And if its value is right, we'll just forward it to the right service. So let's apply this. All right. And the gateway API does not come out of the box in Kubernetes right now because it is still relatively new and you have to install it by applying some CRDs. So I installed these CRDs prior to the talk. All right. So if we make the same request as we did before, it should route correctly. And the only thing that is different here is that we are using the gateway API, but we ended up achieving the same thing as we did with the custom CRDs, right? Now, if we delete it and all right. Now let's try doing something a bit more complicated. We saw how we can rewrite the URL before forwarding to the backend services, right? So for that, the gateway API offers something called filters. And we will use a URL rewrite filter. And we are replacing the full path with rewritten. And the rest of the stuff is same. Match the query and forward it to the service. But I get an error. So it says there is an error validating routes filter.yaml, and it means that it is not able to find what the filters mean in this installation of the gateway API. So the issue is that the gateway API version I installed does not have this feature yet because it is still experimental. And if you are working with the gateway API, you end up having a lot of conversations like this because most of the stuff is still experimental, most of the implementation is still experimental, and the spec is still evolving, and a lot of things might fail to work. And to make the example work, I can install an experimental version or experimental release of the gateway API, install that CRD instead of the version I have installed, and it should work. But it also means that the implementation or Apache API 6 or Nginx or any other implementation of the gateway API should also support that feature. But it is not nearly as good as we want it. So all right, so gateway API and what's next for the gateway API. Gateway API is definitely evolving. More people are trying to adopt the gateway API. More people are trying to make gateway API the de facto standard for managing traffic within Kubernetes clusters. But there is still a long way to go. It is definitely an improvement from the Ingress API, and one of the reasons it was separated from the Ingress API was that because Ingress API is quite stable, but the gateway API is not stable right now. And there are more implementations coming in. Projects like Istio, which is a service mesh, has also mentioned that they will use gateway API as the default API in the future. So the future looks bright, but as you can see, like most of the stuff is still experimental. Most of the implementations are constantly breaking. There are a lot of implementations, but most of them are still in alpha or beta stages. And using this in production might be difficult. So until the project becomes more mature, I would still suggest people to use the CRDs provided by the Ingress controllers, where you have to sacrifice some portability, but it becomes more usable. And gateway API is still a specification. It's still an attempt to make something standard. And whenever there is an attempt to make something standard, it ends up being it ends up creating more standards. So this XKCD comic is mandatory in such discussions because basically, like, there are 14 competing standards, and you want to make them you want to unify them, but you end up creating 15 competing standards. So that could happen, but the indicators show that the Gateway API has a better chance at unifying than most other specifications. And the Gateway API project is still under a lot of development, and people can contribute to this project just by being a user, just by being a vocal user. So you can check out gateway.6.k6.k8.io. All right, that's it from me. If you have questions, I think we have some time, and you can check out the resources by scanning this QR code. So thank you.
Gateway API versus the Ingress one?
You mean like using Gateway API versus?
Yeah.
I don't think the performance will change because the Gateway API is just a specification. So even if you define your configuration in the Ingress API, the CRDs, or the Gateway API, it is implemented by some Ingress controller. And the Gateway API only translates this, is only an API to configure things, but the actual implementation is the thing that influences performance. So changing the specification should not matter with performance. Sorry?
So whenever we strip or rewrite the URLs, we have to handle the routing back or the response to be sent to the, so the stripped or the rewritten part needs to be forwarded as a header to the service, and then you have to respond back to the same URL. Do you think Gateway API eventually would abstract that away from the code and would provide it as a native solution in case of stripped or rewritten so that the response doesn't break?
The response shouldn't break in this example.
Not in this. So let's take example of Prometheus, right? There is an option. You have to specify an option of rewriting the URL to be true to make it respond back to the actual, or basically to load the UI, right?
Okay.
So that you have to specify as a switch at the code level. Basically, Prometheus is handling it at a code level, and any other services as well that you might need to, that might need to response back. So you do the same thing. You handle it at the code level, take that value from the header, and then respond back to it.
Yeah, you can. Ideally, you would be able to do that with.
No. So what I'm asking is, would it be possible to extract that away from the code and it be handled at an Ingress or a Gateway API level? Because that becomes an additional layer of you having to foresee things. So as we've been managing some platforms at our company, and when new people come into Kubernetes and get the whole concept of Ingress, this becomes a really big pain point. They have to, rethink their code and then try to implement all of these things. Which is one of the reasons why people are not very keen on coming to Kubernetes either, because you have to handle all of these things. Or they just go the whole full route as this thing kind of a way. They serve their applications or the services from that own. So there's no stripping or anything else involved.
Yeah, I guess it depends on what kind of application you will be running. If you can extract out that part to a query or to a header or to any dynamic parameter, then I guess you should be able to
That's still the thing that me as a developer would have to do.
Yeah.
An extra thing for me to take care of when coming to Kubernetes.
But you only have to do that once you extract out that variable, then the API gateway or any abstraction you have in front of that can manage that, I guess. Maybe.
So no plans on abstracting it away from the code to the gateway API level?
I don't think so. Maybe because there are a lot of use cases, and if the project tries to cater to every use case, maybe it will become biased. but I'm not sure about how this would be handled in the roadmap. Maybe we can discuss it more. Yeah.
Yeah, so thank you, Navendu, for making us aware about gateway APIs.
Yeah.
And yeah, thank you for audience also to make this session quite interactive and sharing your feedbacks, because I guess this session should be two-way, like it should not be the one-way communication. If the audience will also share their feedbacks or their learnings, it is also always a great for a speaker. And if it's an open source project, that will also need a contributors and maintainers. So I guess Navendu is always open for having the contributions on the project. So yeah, thank you.
Thank you.